Today I welcome you to lecture 25. Always you have to divide them and see so that you will have a clear picture. HCF is nothing but co-primes. I will take an example, not one example. I will take 3 examples. This is the first HCF4, this is the second HCF2. Which one we have to take? Now I will take our favorite method. What is our favorite method? Prime numbers will save a lot of time. LCM of A by B, comma C by D. This will help you to verify your answer in the examination. Very well you can take for fractions. LHS equal to RHS. Hello winners, a warm welcome to your channel Study with Youth Officer. Today I welcome you to lecture 25. Okay, what is 25? What is so special about 25? If you put these 2 here, that will become 25. Because 5 is my lucky number. I'll be very careful with 5 always. Okay. This 25 has 2 numbers, 2 5s. 5 into 5. You have to always see a number in its factor form. Always you have to divide them and see so that you will have a clear picture. Okay. Today I am going to teach you HCF or GCD. HCF means highest common factor or GCD means greatest common divisor. How do you calculate them? Okay. In the last class I have told you how to calculate LCM. Hope you found the lecture very easy, right? If you have any doubts always please comment below. Okay. And today I will teach you HCF. Last time how did I teach you? First I started with the repetition. Okay, in a LCM it should be a multiplication without repetition, right? HCF is nothing but repetition. There we don't take repetition, here we take only repetition. What is repeating? Repetition of prime numbers. Prime. What is this prime? If you take 4 comma 6, you have to divide them into 2 numbers, prime factors. The 6 can be divided into 2 comma 3. Okay. What is repeating in between them? 2 is repeating. So answer is 2. If you take co-primes, what are co-primes? Any 2 consecutive numbers. What are 2 consecutive numbers? 2 comma 3, some 8 comma 9, 2 consecutive numbers which are next to each other, some 12 comma 13. These are called co-primes. Or if you take 2 prime numbers, tell me 2 prime numbers, 2 comma 5, some 7 comma 29, or if you take some 11 comma 17. These are called co-primes. Whenever you take co-primes, there won't be any common factor among those 2. Okay, that's why we take 1 as answer. HCF will always be 1 among co-primes. You have to make a proper note of this. If you take LCM, you will multiply those 2 numbers because there won't be any repetition. Here we want repetition. There is no repetition, directly 1 will be repeating everywhere. That's why we take 1 as HCF. Hope you understood this method. Okay, I'll take one more example. Second method I will start teaching you. Second method is called division method. What is this division method? Okay, I will take an example, not one example. I will take 3 examples. 1, 2, second example will be 6, 12 and 18. Third example will be some 4, 8, 10. Okay. I will take 3 examples and we will try to find. Whenever you are calculating using this division method HCF, okay, how do you find? First, whatever is the small number is there, this is a division. 6 you have to put it here. Okay, whatever the biggest number is there, you have to put it here. When you are calculating for 2 numbers, even if they ask you to calculate for 3 numbers, first you have to find only for 2 numbers. Okay, Now how many times? 2 times 12, 0. Once you get the remainder, whatever is there as a divisor, this is the HCF. When 0 is there, whatever is the divisor, that is called HCF. So the HCF of 6 comma 12 is 6. Now we will try to find for 6, 12 and 18. You can take any two numbers first and you calculate. First I will take 6 comma 12. 6 is here, 12 is here. Okay, how many times? 2 times 12, 0. Once you get the remainder, the divisor will become the HCF. So HCF for 6 comma 12 is 6 and third number left over is 18. Now we have to find for these two numbers. Now 6 is small, we keep it here, big number here. Okay, how many times? 3 times 18, 0. Once you get the remainder 0, whatever is the divisor, this is called HCF. Now HCF of 6 comma 12 comma 18 is 6. Easy. Now we will try to find 4, 8, 10. First you have to take two numbers. How do you find 4 and 8? How many times? 2 times 8, 0. Once you get the remainder 0, HCF is 4. Now you have to take that HCF answer 4 and you have to calculate with 10, whatever is remaining. 4 will be here, 10 will be here. Okay, how many times? 2 times 8, 2 is the remainder. But how much remainder we need? 0. But did we get 0 there? No. What we are supposed to do now? Now, as 2 should always be smaller than this number. Is it smaller? Smaller. Now we have to start one more division here itself. Now you put this divisor here. How many times? 2 times. 4. Now you got 0? Yes. When you get 0, whatever is the divisor here, this will become the HCF. Now, which one you have to put? This is the first HCF 4, this is the second HCF 2. Which one we have to take? Because if you take for two numbers, 4 will be the HCF. But now we have to calculate for three numbers, 4, 8 and 10. Now we have to find HCF for 4, 8 and 10. Answer will be, this will be the answer, 2. Okay, easy. Now why did I take this example? I already calculated for 3 numbers. Why did I take 3 numbers again? Because here if you take 6, 12, 18, whatever is the answer for first 2, it became the answer for 3 of them, 6 only. Here also 6 only. But here, first when you calculated HCF, you got 4. But when you calculated for the next time, you got 2. That's why there is a differentiation there. That's why I want to show you that. And one more thing I will show you here. If you take 6, you can write it as 2 into 3. If you take 12, you can write it as 2 into 2 into 3. If you take 18, you can write it as 2 into 3 into 3. I already told you have to take repetition. 2 is repeating here, 2 is repeating here, 2 is repeating here. 3 is repeating here, 3 is repeating here, 3 is repeating here. You may say now, what if something is repeating, 2 is already there, here 3 is there. Should we take? No, we should not take. We should only take what is repeating. What is repeating? 2 and 3. 2 into 3. Answer is 6. You got 6, right? If you take this example, 4 can be written as 2 into 2. 8 can be written as 2 into 2 into 2. 10 can be written as 2 into 5. What is repeating? 2 is repeating, 2 is repeating, 2 is repeating. Now you can find one more thing here, peculiar thing. Here 2 also there, here also 2. Sir, here also 2 is repeating. Should we take? No, we should not take. Because we are calculating for 3 numbers. So repetition should be there in 3 numbers, not in 2 numbers. 5 is not there, so only we will take answer as 2. Here also answer as 2. Now I hope you got a clear understanding of what is a HCF, and already I taught you LCM as well. Okay. Now I will take our favorite method. What is our favorite method? Prime factorization. Prime factorization. When you are doing prime factorization, in LCM what you have taken? Powers of highest powers we have taken, right? Highest powers of prime numbers we have taken. Highest powers we have taken. But when you are calculating HCF, you have to take lowest powers. Least common multiple, least we take highest. For highest common multiple, we will take the lowest powers. I'll take these examples and we will try to do that. 6 comma 12 you have to find. Okay, 6 how will you write? 2 in 2 power 1 into 3 power 1. 12 how do you write? 2 square into 3 power 1. Okay, answer will be, you have to take the smallest power. 2 power 1, 2 power 2, which is the smallest power? 2 power 1 into 3 power 1, 3 power 1, 3 power 1 only. Answer will be 6. Did you get 6 here? Yes. We will take second example now. What is the second example? 6 comma 12 comma 18. 6 can be written as 2 power 1 into 3 power 1. 12 can be written as 2 square into 3 power 1. 18 can be written as 2 into 3 power 2. What we have to take? Answer, lowest powers we have to take. Answer will be 2 power, lowest power is 2 power 1 only, and 3 power 1. Answer is 2 into 3, 6. Did you get 6 or not? Yes. Easy. Now third one, 4 comma 8 comma 10. 4 how do you write? 2 square. 8 how do you write? 2 cube. 10 how do you write? 2 power 1 into 5 power 1. Okay, so you have to find the answer. What is the answer? You have to find the lowest power. 2 is there. 2 lowest power is 2 square, 2 cube, 2 power 1. So 2 power 1 into 5. 5 power 1 is there. But here 5 power 0 will be there. Here 5 power 0 will be there. 1 is 0 is smaller than 1. So you take 5 power 0 only. 5 power 0 means how much is this? 1. 2 into 1 is 2. How much is the answer? You have to divide two divisions. You have to make two divisions if you use division method. If you take prime factorization, answer will be very easy. Okay, prime, prime, prime. I told you when I was teaching you prime numbers will save a lot of time, and it will show the true behavior of numbers. What is repeating, what is there in the number, how it can be written in different forms, everything. Prime numbers will help you, especially 2. 2 is the only even prime number that will help you a lot. Okay, hope you understood this concept. I'll take some ABCD like I have taken in LCM, that is algebra style. I'll teach you through algebra methods. Can I teach you? Yes, I'll teach you how a coprime acts. Like first example, I'll show in algebra forms. Okay, if you take A, B, B, C, C, D. If you are supposed to find, okay, 3 numbers, how do you find? Before finding 3 numbers, I'll try to find for 2 numbers, AB comma BC. HCF if you have to find, please mind you dear, these ABC should be prime numbers always. Should always be prime numbers. If the prime number is in this form, answer will be, which is repeating? B is repeating. Answer will be B here. If you take 3 numbers, what is repeating here? B is repeating here, but it is not repeating here. Okay, A is there. A is nowhere it is repeating. Even if one number is not repeating in other numbers, okay, one complete number should repeat in every number. If it is not repeating, answer will be 1 directly. These are coprimes. Not 3 members, because you cannot call all of them as coprimes also, because these two have a common factor. These two have a common factor. But if you take this number and this number, this is completely a coprime. Among them, at least if you find 2 numbers as coprimes, Directly you can put the answer as 1. Second example we will take. If you have any number like a square b, okay, b c square, b d cube, directly answer will be b is common, b is common, b is common. Answer is b because no other number is repeating. This is the distinction you are supposed to find. If someone gives you like you have to find HCF for a square comma b square, nothing is repeating, answer will be 1. Easy? I hope you enjoyed this method as well. Okay. In the previous lecture, I have stopped finding for fractions, right? We will find for fractions also. Fractions. We have to find two things here. We have to find LCM also, LCM and HCF also. LCM of A by B, comma C by D. What is the formula I told you? LCM if you have to find for two fractions, numerator LCM, HCF you have to take for denominators, B comma D. If you are finding HCF for fractions, you have to find, if you want to find HCF, numerator will have HCF. HCF of numerator, denominator will have opposite, what is LCM. You have to find for B comma C. We will take some examples for this. Yeah, come on. I will take some 2 by 5 comma some 6 by 7. If you have to find LCM for this fraction, what we are supposed to do now? You have to find LCM for numerator and HCF for denominator. And if you have to find similar example, if you take 2 by 5, 6 by 7, if you have to find HCF, you have to find HCF for numerator and then LCM for denominator. Okay. Now LCM of 2 comma 6. 2 comma 6. If you have to find, this is 2, this is 2 into 3. Highest powers is 2 power 1 into 3 power 1. 6 is the answer. Denominator, these two are prime numbers. HCF of two prime numbers is 1. Easy? Now HCF of 2 comma 6. 2 comma 6 which is repeating? 2 is repeating. Answer is 2. LCM of 5 comma 7. 5 comma 6 are co-primes. There is 2 or 2 prime numbers, right? Now you can directly multiply them. 5 into 7, how much is this? 35. Clear? Okay, good. So far so good? So good. If you take, here I have taken 2 fractions. If you take 3 fractions also same. LCM of all the numerators, HCF of all the denominators. Okay. Now I'll tell you one more method. What is that? The relation between LCM and HCF. What is the relation between LCM and HCF? LCM into HCF will always be equal to product of two numbers. This is for only 2 numbers, not for 3 numbers. 2 numbers only. This is a caution, my dear. Okay, don't take for 3 numbers and calculate like this. This will help you to verify your answer in the examination. Sometimes you may calculate in a wrong way. Okay, that time this will help you to verify your answers. Now we will take these examples. If you take 6 comma 12, HCF is 12, right? What is the LCM? LCM will be 12. You please find it. If you take 6, 12, 18, what will be the HCF? 36. Sorry, LCM this is. I said HCF, right? LCM. LCM will be 36 here. LCM will be 12. And if you take, and we are not supposed to take for 3 numbers, right? So we will not take. Only for 2 numbers we will see now. Okay. Now LCM we know, HCF we know. Now we will try to calculate for LCM is how much? 12 into HCF is 6. Product of 2 numbers is 6 into 12. So you know this is 72, this is also 72. And if you take 4 comma 6, HCF is 2, LCM is 12. If you take that also, LCM into HCF, 12 into 2 is equal to product of 2 numbers 4 comma 6. This is 4 into 6. 12 2s are is 24, 4 6 are is 24. Always this property will hold good. Okay. And sir, should we take this property only for integers? And can we take for fractions also? Yes, you can take for, very well you can take for fractions. Now we will try to find that. What is the LCM of these two fractions? 6 by 1 is the LCM. What is the HCF? 2 by 35. Okay. What are these fractions? 2 by 5 into 6 by 7. Now we will try to see and whether they are equal or not. 6 into 12 6 into 2 is 12 by 35. This is product of two fractions. 2 6 are 12 by 5 7 are 35. So LH is equal to left hand side equal to right hand side. In maths we use, I don't know whether I told you in I didn't tell you in basics, no? This is LHS equal to RHS. That means left hand side, right hand side. When they are equal, then the property is good. Now this is the whole LCM and HCF package, how to calculate them. Okay, we will see a number of examples in the advanced version of the number system. I hope you are comfortable with this lecture and you practice more. Okay, thank you so much. Happy learning and have a nice day.